Oh, I got
Uh-huh. Yeah.
Yeah, I can hear it.
Okay.
It has a delay.
Okay.
Oh my goodness, so tough.
Yeah.
Our topic was
23. 23 you don't have to do, but we're gonna talk about right now. Yeah, that one I said don't worry about it because that one required 2 rules, but we're gonna talk about that today.
I love you.
All right, so shh. With that being said, all right, so we're gonna go to finding horizontal tangent. This one's on the test, okay? And there's multiple questions on finding a test. You're gonna realize I asked finding horizontal tangent a lot. Samuel, did you do your homework? That's it. I don't remember checking yours. I remember checking on everybody else. Who else I did that check? Do you know how to do it? I like your shirt, by the way.
Oh, thank you. And then the page was behind. There was one behind it.
I compliment your hair.
Oh, true, you did.
Yeah. See?
No, W wrist.
W wrist. Okay, chat, can we start? All right, so how do I find horizontal tangent, right? For horizontal tangent, make sure you understand that because I'm going to ask you this a lot. Horizontal tangent is basically dy dx, set dy dx equal to 0 or f prime of x equal to 0. And look for that evaluation. Now, I have this questions here. I have this question because I think that I have f of x is equal to, I'm going to write in different color. So 5x minus 3 to the 4th power. And I have a 3x minus 2 to the 6th power. I have this. I say, hey, can you find a horizontal tangent of this? Now here, before you start, you should think about what kind of rule is in this question. What kind of rule in this questions? Okay. Chain rule and product. Well, why it's product? You cannot just take a derivative of one function and take a derivative of the other function just using chain rule straight. You have to think about the red function and the blue function multiplied together, so it requires product. Now, I want you to do the first line of this product rule. I don't want you to simplify. I want you to do the first line of product rule and chain rule together. See if you can get it without making mistakes. Okay, so a lot of time people forget things here and there. And also, another thing is this. How many people still working math sideways? Can you change that habit? It's working downwards. I think Glider working sideways, right? Start working downwards. You working downwards? Okay, so make sure you work your math downwards, not sideways, sideways. Because this question requires a lot more things going down. And those of you guys have a ugly handwriting, separately write it nicely because it's really hard to, it's really easy to mess up. Samuel, Yasmin. Who else have ugly handwriting? Lyndon has okay handwriting. You have a more ugly handwriting than Lyndon. You're jealous of your own handwriting? You say you're jealous of your own handwriting?
I'm jealous of her handwriting. Her math is like generating.
All right, did you finish taking the first line? That's interesting. All right, so what we're gonna do is we're gonna show you the derivative of this, and that's equal to the derivative of the red function is gonna be 4 times 5x minus 3 to the third times 5. Did you forget the 5? Lee, you forgot the 5.
Not forget 5.
You didn't?
No, I should have checked it.
Okay, now I'm gonna leave the second one alone. I'm gonna add, and I'm gonna leave the first one alone. So which is 5x minus 3 to the fourth, and take a derivative of the blue function, which is 6 times 3x minus 2 to the fifth times 3. Is that okay?
Wait, why is it? Oh. We gotta use chain rule and product rule.
Yeah.
Yeah, red.
Why wouldn't you multiply it already to be 20?
What do you mean 20?
You want to-
Oh, why don't I do that later? Because I just want to write out the line so I don't miss anything. So usually when I finish this line, I double check everything, make sure I don't miss anything. I don't just take a derivative on each individual one. This is a product rule. So you had to have combination product and chain rule, just like what Jacob is saying is like he forgot that was a product rule as well. So you have to know that there's a product rule here, and you double check after you take a derivative before you move on, and then go to the next line. So build a good habit of going discipline of checking your work before you go to the next line. Do you guys ever remember Big Bang Theory?
Yeah.
There was one time like Sheldon showed like Stephen Hawking his math work, like his theory about something, and Stephen Hawking just stare at it, just say you make an algebra mistake, and Sheldon got like crash out. Yeah. He got crashed out literally. He just like, oh my god, I can't believe I make that stupid mistake. So you don't want to be the one that doing that. You just want to make sure you double check your math before you move out. So I'm gonna factor out the most negative power, the GCF, most negative GCF. So what I mean by most negative, so if you look at a 4, you look at 4 and 3, which one's more negative? 3. So I'm gonna factor out this. Right, I'm gonna factor out this 3. And you look at a 5 and 6, which one's more negative? 5. And there's a reason why I say most negative, because later on you do have to deal with negative powers. So therefore it's gonna give you the red is gonna be 5x minus 3 to the third power. And if you factor out the blue, it's gonna be 3x minus 2 to the fifth power. And once you factor out, I'm gonna have the purple left, which is 4 times 5 is 20 times by 3x minus 2. And a plus 18 times, because 3 and 6 is 18.
No, it's 8. Oh, I 5 times 4 times 5.
6 times 3 is 18, and then you have 5x minus 3 left. Is that okay? And now you recognize that I just do algebra. I didn't do anything crazy. Which one do 5? This 5? Because 5 and 6, which one's the least power? You compare 5 and 6. Okay, can you guys see in the back, Emma and then Patel, can you see in the back? Okay, now I'm gonna simplify it more, so that's gonna be 5x minus 3 to the third power, and that's gonna be 3x minus 2 to the fifth power. And then this one here, I'm gonna distribute that, so it'll be 60x minus 40 plus 90x minus 54, I think. And that's gonna give you 150x. You have 150 kicks left, and you have minus 94. So this is 3x minus 2 to the fifth. This is a 5x minus 3 to the third. Now again, this is red. And this is blue, and the last one is purple. So I color code everything for you, just so you guys can see it better. 18 times 5 is 90, right?
Yeah.
Is this okay? Now, did I solve for horizontal tangent yet? No.
Yeah.
I have to set each one equal to 0. So that's 150x. So x equal to 94 over 150. You can probably simplify it down to, I don't know, 47 over 75. This one's going to be x equal to 2 over 3. And this one is going to be x equal to 3 over 5. Okay, so just tedious math. Now, some of you guys says, okay, I aspire to be an engineer. Guess what? You had to get through the tedious math. Yes.
Can you explain why the 20 goes in front of 3x minus 2 and the 18 goes in front of 5x minus 3?
Yeah, because the 4 and 5 is 20. And you have 3x minus 2 left when you factor out 5x minus 3 to the third power, which is everything here. Then you have one more thing left because you only factor out to the fifth power. So you have 3x minus 2 to the fifth power. So you're gonna minus 3x minus 2 to the first power because you factor out a fifth. And you because 6 minus 5 is 1, so this is 1, and you have 4 times 5 is 20.
And so wait, would it be 3 minus 4? Make it 5x minus 3 to the negative 1?
Huh?
Are you doing left to right?
Winston, can you help him out?
Okay.
I have no idea what he's saying.
No, why are you saying I can't put what I'm thinking into words properly? It doesn't matter. My thoughts are just too high level into words.
But just put the 20 in front of 3x minus 2 and the 18 in front of 5x minus 2.
I think he had the same question.
Yeah. I took a 2 out. So
You take a 2 out?
yeah.
Which
20
2?
and 18.
Oh, you take the...
Yeah, I factored 2 out.
Yeah, you can if you want to, but I don't have to. You can factor out 2 at the very beginning because 6 and 4, they have common factor of 2. Yeah, you can do that. So what I'm trying to say is, look at this term, right? You already take out, this is 4 and 5, and that's how you get 20. Is that okay? 20 is there? It's 4 times 5. But you factor out this completely. Look at this. You factor out this completely. You only factor out because you only factor out 5 out of 6. So you still have 1 left. 3x minus 2 left.
Yeah.
Because you factor out 5 fifth power.
Okay.
And you do the same thing for the other side. Jacob, you got it?
Yeah.
Okay.
Yeah, so you can't factor it 6.
I want you to try again on this one. Just make sure you can work through the tedious math. Now you do realize every no question I do is always on the test. So this is always on the test. And it's not on the test, I would tell you it's not on the test. I'm a very fair person, so you guys have to just figure out how I function. the right answer?
Yeah. That makes more sense.
Um, you guys should get the same thing as x equal to 2 over 5, x equal to 2 over 7, x equal to 110 over 315, which is equal to 22 over 63. Yes?
Do we need to simplify for the question here?
Well, if you get 110 over 315, I'm happy because that means your factors, right? Yes. Yeah, it means that, you know, in the AP exam, they don't care if you're giving non-simplify. So if you use 110 over 315, most math teacher, when they grade it, they know. But the problem is that MCQ is only going to have 22 over 63. So you have to know how to simplify it regardless. So how to factor x4 minus x squared? We already know how to factor this, the first one. I'm sorry. Why are you so slow?
What you mean slow? This is the first time I've ever done a problem like this.
That's
It's gonna take more than 2 minutes. I'm new to this.
You a what? What'd you say, Lee?
He's new to this.
He's new.
I'm new.
35.
The part where you have to like 70x minus 70, one right above that. I switched like the. How do you know which one to times 35 by which one times 75?
I depend on what I factor out. So I factor out the first term. If you look at the first term, I factor out this, right? So I have 2 minus 5x left. Because I only factor out the 3 power. This is a 4th power, so I only factor out the 3 power.
Sensei, are you proud of me, Sensei? That gets missed. There we go.
All right. So let's talk about how to factor this. The GCF is x squared. It's fairly easy. You see, you factor out the most negative, right? The x squared is more negative than x to the 4. So x squared you factor out. But once you factor out, you subtract the 4 to the 2. So you're going to get x to the square. You subtract 4 minus 2 equal to 2. That's how you get 2. And this is going to be 2 minus 2 is equal to 0. So anything to the 0 power is 1. And you can factor x squared, x plus 1, and x minus 1 because difference is square. However, this one's a little bit different. This one is the negative power. You're like, wait, why do we need to do this, first of all? Well, first of all, when we go to the end, we will show you why we're doing this. But which one's more negative? So we're going to factor out negative 4. Now, remember, once you factor out, you subtract the power that you factor out. You subtract the negative 4 from negative 2. So, no, it's not negative 6. Negative 2 minus negative 4 is negative 2 plus 4. That's equal to 2. So that's going to be x to the 2 if you pay attention. And if you factor out negative 4, so it would be negative 4 minus negative 4, that's equal to 0. So that's going to be 1. And then that's going to be x plus 1 times x minus 1 all over x to the 4. Now, why do we have to go through here? Because that way we can find horizontal tangent, we can find vertical tangent, we can find vertical asymptote, we can find all the things about this function. So it's actually nicer to be in the fraction form. Yes.
Is it almost always going to be -1 in parentheses?
Don't know what's minus 1 come from. I didn't see any minus 1.
You don't see x squared minus 1.
Oh, because you factor out x to the negative 4, so You think about it, you distribute back, you're gonna get this. You distribute back, it has to be x minus 4. It doesn't have to be -1. It could be -2 or -4. It could be any number.
Give us something harder.
Yeah, that's about to. So now we got this function here, and we say, hey, can you find the derivative? Let's find the derivative, and can we simplify all the way? And I want you to be able to simplify all the way. Chain and product, and what else? There's one more.
No quotient. No simple.
What?
Not quotient.
Not quotient, good. There's one more rule that you have to be involved. Power rule, right? So there's power rule, product rule, and chain rule. But this time, I want you to factor out the most negative power. Now, not a lot of people are able to do this because I'm going to show you how to do it. If you're really confident, you can try it and you have a very solid algebra skill. Like, I think the people who have strong algebra skill here are Lian and Andy. Miranda, Winston have strong algebra skill. Oliver has strong algebra skill. Lee has baby. Baby. Who's a baby? He's just a baby. But I want you to take a derivative first. If you don't have strong algebra skill, don't go to the next step. If you have strong algebra skill, go to the next step. Challenge yourself. Okay, Kaden.
False confidence, believe me.
So I'm going to go ahead and take a derivative of this. Take a derivative to x squared. Really easy. 2x. I'm not going to using radical, so I'm going to using 1 minus x squared to the 1/2 power. Is that okay for you guys? I'm not done yet because there's product rule coming. This has to be a plus sign in between, right? I'm going to write down plus sign. And then derivative of x squared, which is 2x. And then that's going to give you x squared, this takes. And I'm taking derivative of this part, which is times 1/2 times 1 minus x squared to the negative 1/2 times negative 2x. Now, for me, like I will look for simplification first, always. Do you see that there's 2 here? Can cancel out this 2. Do you see that? That 2 can simplify, make my life easier. I don't have fraction. I mean, even if you don't have fraction, you can probably do that, but then what I'm going to do is factor out the most negative. Now, pay attention. I'm going to factor out each side, they both have x. We're going to factor out this x right here. And we're going to factor out this x right here. Is that okay? And then for the green one, I'm going to factor out the most negative, which is negative 1/2. So I'm going to write that. I'm going to write down x in the front, which is a blue, which is the green. I factor out the x. And also factor out the red, which is 1 minus x squared to the negative 1/2. And then I have whatever left over. So now the first part here, what do I have left? I have 2. Good. What else? Since this is going to be 1/2, you factor out negative 1/2. What am I going to get? What's 1/2 minus negative 1/2? That's going to be 1. So it'll be 1 minus x squared to the 1, right? And now if you factor out the x, which is the green part, which is I factor out as x, I do have x squared left, so like look like this. Do you see that? Because the x at the end you factor out the green part. I color code this. This x, I factor out this x, and I have x squared left. You just keep a track of everything. Yes.
What did you do with this one?
I factor out the x and I factor out this. So I left with the 2, and this 1/2 power changed to 1/2 minus negative 1/2 because you factor out negative 1/2, so it's gonna be plus 1/2. I cannot factor out 2x because this 2 cancel out this 2, so not both sides has 2x now. Because there's a negative sign still.
Yeah, but from the term on the right, you factor out x. Wouldn't that make like the remaining x squared is x?
I don't know what you're saying.
He's asking about the negative x squared in the bracket.
Yeah. So this is an x squared, right? So we know x squared, but there's a negative sign. There's a negative 1 because you factor out x, still negative 1 there. And the 2 cancel out with this 2, so it's still negative 1. So this will change to negative 1 here. So that's why it's a negative x squared.
Oh. The 2x from 2x and back.
So I'm gonna go ahead and simplify the purple part. So it'll be 2 minus 2x squared minus x squared, and that's gonna be 2 minus 3x squared. And the red part is the green part is the x, and the red part is 1 minus x squared to the negative 1/2. Now I'm gonna move that to the bottom, so it'll be x times 2 minus 3x squared to the 1 minus x squared to the 1/2. So that should be a final answer. Because I moved it to the bottom and become. So this one's probably the most difficult one because you had to factor out the least power, the most negative power. I'm gonna give you a question. I'm gonna give you answers. So that way, this is your first homework question. So that way, at least I give you answers first.
Could you zoom in on it, on the answer?
I think
Thank
it's
you.
still both people with that answer.
Yes.
Can you explain what you did with the twos again? I don't get how you did it.
This 2 and this 2 cancel out. This 2 and this 2. Because the 1/2 times 2, the 2 is gonna cancel out with 2. So it's like 1/2 times 2. That becomes 1.
Oh, you did, oh, okay.
You just mark the x, everything. If it's 2x plus x squared minus 2x. If you factor out 1x, it's gonna be 2 plus minus 2. I think you have that. It does. Yeah. Well, I think you are more in the part.
Alright. What we're gonna do is we're gonna start with this question. Okay, so we're gonna say, hey, we're gonna tell you the derivative of it. We're gonna tell you the answer because this is the first homework question that you're gonna get. So this is the first homework question, and there's an answer here. But I want you to practice another test question because this one's gonna be the test question about this is gonna be easier than those 2 questions. So I'm not too much worried about it. If you really understand one of them, it's good enough. But there was a practice. So this is the first homework question of the first questions right here. There was an answer. I'm gonna show you the answer. So that way, when you do it, you don't look at the answer first. You work it out, see if you can get an answer.
That 3x squared plus 4 plus 4 over 3?
Yeah. Okay, so, but I'm not worried about this. I'm worried about this question. That yesterday at the end of the class, I talked about this. So how do I take a derivative of this? Because this is one of the homework questions. And this is a homework question. I'm going to give it to you. And there's also a test question as well. So is secant, no, actually tangent to the 4 of secant of square root of x. I want you to take a derivative of this function. I want you to take a derivative of this function. But this is the one of the question on your test. Huh? Yeah. The reason why I ask this question is because I can ask this kind of stuff and I can ask you all the tricks, see if you know your trick derivative. For me, that you have to make sure that you know all the trick derivative. So make an index card, say derivative sign is equal to cosine, derivative cosine is equal to negative sign.
Tan sec.
Yes.
Yeah, I know that one. You gotta tell me the other half. So
I cannot tell you the other half. No.
No. If you're gonna have, you have to say you have 6. No, bro, that's the derivative. Derivative is tan. If you have a tan.
That's a weird conversation, right? It's all live streaming too.
Yeah.
I hope live stream cannot pick up that far.
Because you have to take the derivative. Okay.
It's like, what do you learn in calculus class?
So take the derivative first, and then take tan. And then take tan, and take secant, and then take derivative. Secant, if you're sec, you wanna have no, yeah, exactly. You wanna have sec. Yeah.
Winston, we're live streaming this.
But I'm learning, brother. No, it's 1 over 2 times Does that make sense? Oh, yeah, it would be negative minus 1 over.
Now, there are 4 layers here. So I'm gonna start with the blue layer. The blue layer is gonna be the something to the 4th power. Something to the 4th power, if you derivative, is gonna give you 4 10 to the 3rd power times secant of square root x. Now remember, like in a Russian doll, like inside the doll, so you remove one doll, then all the inside doll still inside. Does that make sense? So then I'm gonna take the purple one. The purple one's the easiest to make mistake because, oh no, the purple one's fun. It's gonna be derivative 10 is gonna be the secant square of secant square root x. Okay, so now I'm gonna take a derivative of secant square root x. Now take a derivative of secant square root x. I feel like a lot of people is gonna make mistake here, because the square root x still inside the secant. So therefore, that's gonna be secant square root x tangent square root x, not just secant and tan. The inside still inside here. And the times the derivative, the brown one, which is 1/2 x to the negative 1/2.
Yeah, it's not adding, so then you gotta like.
You want me to move? Okay. Do you guys understand? I mean, that's fine. If you want, if you got it this far on the test, I'm giving you credit. All the full credit. Ken, that one goes this way though. Ken, that one goes this way.
We're gonna do a little homework tonight.
When you think like everyone like quickly going you finally and then it all comes out. No, I love
Have a good day.
If there's a question like that on the homework, we don't have to combine, or we did.
On the test, I'm okay with doing like that. But if you can combine, you have good math skills. But I won't take a chance yet until you have.
If
better
I
math
combine it and get it wrong, but I do,
skills. Then don't risk it.
don't risk it.
Yeah.
All right. I won't.
Bye, really. Stratford, move all this chair over. So, and if you need help, you need a student help you or no? You need a student help you? Okay. Move it this way. So. No, this mainly this few chair here. Because he's putting it on this side.
I have a question. Do you know what? Wait, did I get it? Do you know what this means? Can I tell you Kobe Bryant?
Triangle.
Bruh.
It's probably by Phil Jackson. But he's not the only person who does that. Everyone does it.
Wait, what is it?
What's going
What does it mean?
It's triangle offense. He's the only coach that runs triangle offense. This is triangle.
No, but like they with their fingers
Yeah,
up like
that's what
this.
these are at Nike.
It's
Gold,
50,
52.8.
Yeah, you know, I was talking
That's
to
triangle
you.
offense.
I just.
I hope you put 52.8.
I did.
So what
I
is
saw
it?
you did the wrong one. Wait, it's not right.
I didn't even answer that question right. Wait, I did great.
Huh?
Did great.
Oh.
26, 52.8. Everyone who 26 got it wrong.
For what?
For the first,
Elvin.
First question.
I was gonna tell you to ask you.
No, he was like, he did it. And I was like, no, it's not.
I feel like I did.
Hayden. Hayden.
40 out of 25?
Wait.
Hey, hold the other side.
Oh no! He said that yesterday. You know, like, there's always one, if not one senior, there's at least one junior who did well, and it's not going to Kirby.
What'd you put in? You blocked my.
You're Aiden, that jersey more up.
Horrible.
Yeah, it is.
Look hot.
Our next math department meeting is on October 1st at 1:30 p.m. Please feel free to come to us. Just be sure to be prepared for questions.
Bro, that question was actually hard, man. I'm glad that I used it. I had movie to say that, and I thought you're not the one you're
At 3 p.m. I was awake for 3 hours.
there's no doubt.
Because I like I with the 10. I went out. I got I missed it. I forgot, dude. I was sleeping. I was gonna go shoot everyone is like so
You won't see here, Mr. Man. They are.
Get the other, get the. Like all the way up.
Man, I actually should have.
And then he said, moral of the story, continue.
Feels real like.
All right, so shh. want to talk to you about something which is the math competition. We are hosting a math competition here at January 24th. We need volunteers that day. And so hopefully you guys can help out. Competitions wise, we are still finalizing the teams, but I don't know. I know the senior teams, the people on senior, I'm gonna put on the team 1, and team 2 is probably gonna be a lot of juniors, and but I have more junior than the team members, so I want to have a friendly competition among you guys to see where you at. Also, I'm coordinate with a bit. A bit is gonna he's gonna do integration B in UF. Actually, so integration B is like just like they give you integration problem and you have to figure out where to integrate it. And he's happened to be very good. I'll also ask if I don't think they will have any time, but I think a bit says he doesn't mind. But I'll also ask Anthony, or I'll ask also as well. Shh, cooking. Yeah, thank you. I will also ask Anthony and Sophia see if they can help out. Now, I need somebody in charge, and I asked Lucia yesterday. Lucia says she have a lot of things on her plate as well. Because she's gonna help me a lot with math competitions. Yeah, she's gonna help me with math competition. She's had to coordinate a lot of things. She's had to deal with a lot of things. So far as the team wise, I do need some responsible people, and both me and Lucia feel like since Alejandra and Christian is kind of like coordinate. You guys are like competition officers, so you guys gonna find a way to coordinate that with a bit and then just kind of go through as many problems as possible. I do find a very cute kid, about 12-year-old, and and this cute kid that he does a phenomenal stuff. He does a phenomenal stuff. Very, very